Hello viewers, welcome to the brand new video of Revit structure. This side Anupama, your trainer. So today's video is the second part of the complete tutorial series on Revit structure. So we have already covered our first part. So the topic which we have covered in our first part is that how to import our file from AutoCAD to Revit structure. Then we have modeled our complete structure in the Revit structure. Then we have exported our model to robot structure analysis. So today's video will be all about your robot structure analysis software. So guys, let me take you through once the topic that we are going to cover today in this video. So the topic that we are going to cover are how to define loads in robot structure analysis, how to apply loads, how to do the code selection, how to do the run analysis, reinforcement detailing for all the structural members, how to do the load combinations, design of foundation as well, and lastly we are going to see how to solve the error problems in robot structure analysis. So guys, if you haven't watched the first part of this complete tutorial series, then go and watch it first. The link is attached in the description box below. And if you guys are really interested in learning the complete detailed course on Revit structure, then you should go and visit our official application and go through once the course which is provided there. It's a complete detailed course from basic to advanced level. All the topics are covered there as per industry standards. You will definitely like it. And if you are not subscribed yet to our channel, then go down below and please subscribe our channel and also hit the bell icon so that you get notified whenever new video is uploaded. So without further ado, let's quickly jump into the video. So let's start with robot structural analysis, okay? But before starting to work with my model, let me take you through some of the common basic commands that are used in the robot structure analysis. But हम लोग जब धीरे धीरे काम करते रहेंगे मॉडल के ऊपर तो आप लोग को पता चलता रहेगा क्या क्या कमांड्स है, क्या क्या एलिमेंट्स हम लोग यूज़ कर रहे हैं. बट फ़िलहाल मैं कुछ चीज़ें आप लोग को बता रही हूँ, ठीक है? जैसे कि दिस इज़ द वर्क स्पेस, ओके. सो हियर आप लोग देख रहे हो कि वी हैव ऑलरेडी एक्सपोर्ट द मॉडल हियर. बट बेसिकली आप अगर देखो तो वी कैन डायरेक्टली ओपन आवर रोबोट स्ट्रक्चर एनालिसिस फ्रॉम हियर और हम लोग वी कैन स्टार्ट आवर न्यू प्रोजेक्ट, ओके. वी कैन स्टार्ट आवर न्यू प्रोजेक्ट or we can open our project, okay. So there is a folder, okay, I'll show you later maybe that हम लोग वहाँ से अपना new project भी start कर सकते हैं and we can open our project which we have already worked or which we have saved, okay. So there is a different option. And यहाँ पर जैसे कि हम लोग ने ऑलरेडी मॉडल को एक्सपोर्ट किया है, बट वी कैन ऑल्सो प्रिपेयर हियर आवर ओन ग्रिड एंड स्टार्ट वर्किंग फ्रॉम द स्टार्टिंग, okay. We can also prepare our model here and then we can start modeling or doing the structural detailing here as well, okay. पर जैसे कि हम लोग ने इसको एक्सपोर्ट किया है तो ऑलरेडी हमें यहाँ पर मॉडल हमारा रेडी है, तो हमें सिर्फ इसका स्ट्रक्चरल डिटेलिंग के ऊपर वर्क करना है, ठीक है. बाकी का जो है वो अलग से है, हम लोग अलग से इसका ग्रिड भी क्रिएट कर सकते हैं जैसे कि हम लोग दूसरा सॉफ्टवेयर में करते हैं, ठीक है. सो आप देख सकते हो यहाँ पर हियर इज़ एन ऑप्शन कॉल्ड एक्सिस डेफिनेशन, ओके. सो ये एक्सिस डेफिनेशन के थ्रू हम लोग बहुत इजीली हमारा ग्रिड प्रिपेयर कर सकते हैं इन द रोबोट स्ट्रक्चर एनालिसिस, ओके. सो नॉर्मली हमारा 3 ऑप्शंस रहता है, एक कार्टेशियन, एक सिलेंड्रिकल और एक आर्बिट्ररी. तो ये 3 ऑप्शंस को के हेल्प से हम अपना यहाँ पर ग्रिड प्रिपेयर कर सकते हैं जस्ट लाइक अदर सॉफ्टवेयर, बट इट टेक्स very less time and it is very easy to prepare here, okay. बट अभी हमें फ़िलहाल इस ग्रिड को नहीं प्रिपेयर करना है, हमें यहाँ पर स्टार्टिंग से मॉडल नहीं बनाना है, हमें बस अपना रेविट मॉडल को हम लोग ने एक्सपोर्ट किया हुआ है उसके ऊपर हमें स्ट्रक्चरल वर्क करना है, ठीक है. बट मे बी इन फ्यूचर मैं आप लोग के लिए इसके ऊपर भी एक वीडियो बनाऊँ, ठीक है, दैट हाउ टू क्रिएट फ्रॉम द स्टार्टिंग टू टिल एंड, ओके. So this is the workspace, okay, and this is the object inspector, okay. So this here in the right side you can see there are different elements over here. Okay, through these elements we'll be doing our modeling. Okay, we'll be using all these elements, okay, in our project. Okay, so जब हम लोग एक एक करके elements यूज़ करते रहेंगे आप लोगों को समझ में आता रहेगा कौन सा कब क्या यूज़ करना है. ठीक है, एंड दिस इज़ द योर मेन्यू बार. ये हमारा मेन्यू बार है. ठीक है, सो यहाँ पर डिफरेंट ऑप्शंस है. ठीक है, एंड द फर्स्ट एंड द फॉरमोस्ट थिंग इज़ दैट सबसे पहले हमें कोई भी प्रोजेक्ट स्टार्ट करने से पहले हमें यूनिट सेट करना बहुत ज़रूरी है. ठीक है, सो हमें कहाँ से हम लोग यूनिट्स सेट कर सकते हैं यहाँ पर. सो आप लोग देख सकते हो इट इज़ वेरी इजी हियर. ओके, हम लोग यूनिट बहुत इजीली यहाँ पर सेट कर सकते हैं. जैसे कि आप लोग देख सकते हो एकदम नीचे राइट कॉर्नर में मीटर, किलो न्यूटन, डिग्री. सो अगर आप लोग यहाँ पर क्लिक करोगे देन यू विल सी हियर दैट यहाँ पर जो प्रेफरेंस है आपका, अगर आप यहाँ पर यूनिट्स एंड फॉर्मेट्स में क्लिक करोगे देन यू विल गेट टू ऑप्शंस हियर. डिफ़ॉल्ट यूनिट्स लाइक मैट्रिक एंड इम्पीरियल. ठीक है, सो ये बहुत इजी होता है. अगर आप यहाँ पर मैट्रिक क्लिक करते हो, डू यू वांट टू चेंज ऑल यूनिट्स फॉर मैट्रिक यूनिट? येस. ओके, सो आप लोग देख रहे हो यहाँ पर मैट्रिक पे है मीटर, किलो न्यूटन. अगर सपोज़ आप लोग इसको इम्पीरियल कर दोगे, येस, सो आप देखोगे यहाँ पर आपका चेंज हो गया है फिट. ठीक है, सब यहाँ पर चेंज हो गया है. सो सिमिलरली पहले आप यहाँ से अपना यूनिट, बेसिक यूनिट चेंज कर सकते हो. देन यू कैन गो विद द डायमेंशंस. आपको क्या डायमेंशन रखना है. ठीक है, फोर्सेस क्या रखना है आपको. यहाँ से इन द ड्रॉप बॉक्स सारा यहाँ पर यूनिट्स अवेलेबल है. मोमेंट्स क्या रखना है. ठीक है, लेंथ इनटू फोर्स. ठीक है, देन स्ट्रेसेस आपको क्या रखना है. जैसे डायमेंशन में आपको यहाँ पर सारा डायमेंशन मिल जाएगा. ठीक है, रेनफोर्समेंट एरिया, आपका सेक्शन प्रॉपर्टी, सेक्शन डायमेंशन, स्ट्रक्चर डायमेंशन, हर एक के लिए यहाँ पर अवेलेबल है. ठीक है, सो डिस्प्लेसमेंट, एंगल, रोटेशन, टेम्परेचर, वेट, मास. ओके, सो ये यहाँ से हम लोग बहुत ही इजीली हम लोग अपना यूनिट सेट कर सकते हैं. ठीक है, now if you want to see the extruded beams and columns here, then for that what you have to do, just in the left hand corner you will see there is an option called section shapes. Okay, just click on that. Now you can see the beam and columns. Okay, and then here the slab, you cannot see the thickness over here, isn't it? So for that what you have to do, just right click and here there is an option called display. So go to display, then here you will get a dialog box. From there you have to choose panels. Okay, just click on that. Then under filling the interiors you will be getting an option called panel thickness. Okay, just click on that and here apply it and then click OK. Now you can see the thickness of your slab, the staircase slab. Okay, this is the mid landing beam. Okay, this is the slab, this is the mid landing slab. Okay, see how good it is looking here. Okay, now the next thing is that we are going to define the loads. Okay, so how to do that? So next we are going to define and apply our load cases, and we are going to see how we can delete the existing load cases if there is any. Okay, for that in the right hand side you have to go to the option called load types. Okay, so here you will find the two options like load definition and load types, but you have to go with the load types. So just click on the load types. So you will see a dialog box over here where all the different kind of loads are listed here. Okay, and here all the natures, labels, sub natures, everything is mentioned over here. Okay, so as of now we don't need the wind load here, so just select it and you can delete from here. Okay, so just click on delete. So let us delete all those snow loads, we don't need these, as well as like temperature. Okay, so we are not considering all this, so we are only going with dead load and live load. Okay, so just select the dead load. Okay, so I'm going to change the name from here, I'm going to make it dead load only. Okay, so just you have to click here, just you have to not add here, you have to just click on modify. Okay, you can also change the level here, I'm changing it to DL only, and just click on modify. Okay, and then the second, that is the live load 1, so I'm also going to change it. Okay, I'm only keeping it as live load. Okay, and I'm going to modify it this, change the level as well and make it live load, and this one is also modified. Okay, and you from here you can change the category also, sub nature. Okay, but one thing is that from here you can change the number as well. Suppose it is the dead load is in number 1, you can change here. Suppose you can write here 3, suppose, and if you modify it, okay, then you can see it is written in third number. Okay, but as of now we'll keep it as 1 and just modify it. So now I'm going to show you how we can add our load cases. Okay, for that what you have to do, just go to the name here, the case description. I'm going to add your superimposed dead load. Okay, and the number here, it will be your 3 number, it will be 3, and level, it will be similarly superimposed dead load. Okay, nature, the nature will be your, of course it will be dead load. Okay, so just now you have to click on add. So you can see it is added here, dead load 2, but we want to change it, we want to keep it as superimposed dead load. Okay, superimposed dead load, modify. So it has changed as superimposed dead load. Okay, then next we have already defined the load cases here. Now we are going to apply the load cases. Okay, so just close it. So guys, we have already defined the loads. Now we are going to see how we can apply the loads, okay, in our structural members, in the slab, in the birds. Okay, so for that we have to go to the option called load definition. Okay, so but before applying the load, let me tell you one thing, that here in this particular video I'm trying to keep the loads and the things very simple. I'm not going to make it complex. Okay, as we have only considered 3 loads, as you know that I have considered the live load, dead load and superimposed load. Okay, and not any other loads. So I'm trying to keep the calculations very simple, okay, as much as possible, because I want to in this particular video I want to keep it simple, and I just want you to become familiar with these commands. Okay, later maybe in the future I will be making some videos on some complex calculation, but right now only some simple calculation, so that you become familiar with all those commands. Okay, so if you want to apply the loads in the slab, okay, so for that what you have to do, you have to select the slab, isn't it? So let us select the slab here. Okay, so we have selected the slab. Then we can go to the load definition. Okay, there are three options like node, bars and surface. So we are going to choose the option surface. Okay, but the thing is that as we are going to apply the load on all the slabs, okay, so now we are not going to select one by one all the slab, because it will take a lot of time. Okay, it will consume a lot of time. So how to select all the slab in one go? Okay, so let me tell you what you have to do. You have to go to edit, okay, and there is an option called select. So from here you will get the option called bars case. So actually it's very easy to choose the members here. Okay, you can easily choose all the members, but as of now we are selecting the slab. Okay, so we are going to select the panels. Okay, so just click on panel. Okay, then as soon as I have clicked the panel, you will get the different options here. So let me show you. If you select the 150 mm slab, okay, and just click on this option, okay, then you can see all the slabs of all the floors are selected. Okay, because it was of 150 mm, isn't it? Now suppose if you select this and if you press Ctrl and select the other slab too, that is the 200 mm slab, and you transfer it, then you can see that all the slabs are selected here. All the staircase slab, mid landing slab, all are selected here. Okay, and from here you can just add it from here, you can just subtract it from here. Okay, this is the options. So we have already add these two. Okay, and just now close it. Okay, so now it will become very easy, isn't it, to apply the loads, because all the members are selected, all the slab panels are selected in one go within a few seconds, isn't it? So just go to load definition. Okay, but before going to load definition, you have to do one more thing, is that from here you have to select the loads which you are applying now. Okay, so right now I'm selecting the dead load. Okay, then go to the load definition. From here obviously we are going to the surface option. In surface you will be getting the different options here. So I'm going to select the uniform planar load. Okay, so the values we have to put here x, y and z. Okay, so you can see here that z, this is the z direction. Okay, so we are going to apply load against the z direction, remember that. So in z we are going to keep it as minus. Okay, and I'm considering here a load, dead load of minus 1.5 kilonewton per meter square, minus 1.5. okay, now just add it and apply it. Okay, and now close it. Strong. Apply. Okay, so you can see the loads are successfully applied here in all the slabs. Okay, so in a similar way we are going to apply the other two loads, that is the live load and your superimposed load. Okay, so let's select the live load, then go to load definition, surface, same procedure. Okay, so I'm going to change the value of Z, so it will be minus, because we are going to apply loads against the Z direction, so it will be -1 kilonewton per meter square. Add. Now apply. Okay, then go to superimposed load, load definition, surface, minus 0.5 kilonewton per meter square. Add. Apply. Close. So now we have done the slab part. Now let's apply the load on the bars. Okay, so for that, similarly, just unclick here. You have to first unselect all the members, then go to edit and then select. Okay, so here we are going to choose bar. So just click here, let's click on control and select it. So we don't need the columns here right now, so just click here, unclick, click here. So here we can select, unselect it, just pressed on control and select whatever you want to unselect it. Okay, so right now I don't want this column. One thing is very easy here, that you can select as per the sections. As we have taken the beams and columns the similar size, so it has been selected. Okay, so I don't want this. Hopefully all members unselected here. There's a column. Yeah, now it's okay. So from here I'm going to select the superimposed load. Okay, and then go to load definition. Now we are going to select your bars, and here there's a different option: uniform load, trapezoidal load. Okay, so I'm taking it as uniform load and I'm entering the value of -5 kilonewton per meter square. Just add it and just apply it. Okay, But remember one thing, whenever you add all those loads, you have to keep here, you have to see here the case number. Okay, so just now I have taken the case number 3, that is a superimposed load, so it has shown here case 3. Okay, so just apply it, apply, suppose if you click your live load, then it will show here case number 2. Okay, then dead load, it will show here case number 1. So make sure to check this once before you apply all the loads. Okay, now one thing I want to show you from here, from go to the geometry. Okay, and from here go to loads, then here you can see all the loads over here, particularly single loads like dead loads. Then all the dead loads will be shown here. If you select here live loads, okay, then all the live loads are shown here. If you select the superimposed load, then all the superimposed load are shown here. Okay, and then you have to go to back to the if you want to go back to your model, then just go to structural model, geometry. Okay, so this is how you can apply. So now I'm going to show you how can you select the codes. Okay, so whatever codes you want, whatever codes you prefer for your project, how to select that. So for that you have to go to tools. There is an option called tools. Under tools there is an option called job preference. So click on job preference. In the left hand side you will see there is an option called design code. Then just click on that. Then here the different codes needed for all the different options are present here. For RCC struct, for geotechnical, for timber structure, for steel connection, steel and aluminum structure, for all different structures. Okay, all the codes are available here. So for RCC structure, if you click here and if you go to more, then you can see that there are different options over here. All the different countries have different codes. Okay, so for India it is IS 456 2000. So you see, you can see all the options for all the different countries over here. USA, Thailand, Japan. Okay, so let me show you how to select that. Okay, so I'm selecting suppose if I'm selecting this code like BS8110, so it is already present here. Let me select some other. Yeah, it is not selected here. Let me select IS 456 2000 and just click on this and click on this and click on OK. So you can see now we have selected this IS 456 2000. Okay, so from this drop down box menu you can select your codes, which one is your preferred one. Okay, whichever you prefer you can select from here, then just click on OK. So this is the way how you can select your codes. Okay, the next thing what we're going to look is that meshing. So normally why meshing is done, generally meshing is done so that the proper load transmission occur from the slab to the beam to the column. Okay, so the basic point is that we use the meshing only to do the proper load transmission. Okay, from the structural members, from slab to beam to the column. Okay, so for that you have to go to analysis tab, and there is an option called meshing here. Under meshing you will find different options for meshing here. As of now I am clicking on default option. So you will see a dialog box here that no panel selected for this operation. Do you want to perform this operation for all panels? Yes, exactly, we want to operate it for all the panels. Okay, so we want our load to be distributed properly, okay, from slab to beam to the column. So we have to click here, yes. So you can see the meshing is done properly. So this is the way how you can do the meshing. Okay, so next, now we are going to analyze our model. Okay, so we are going to do the run analysis, but before that we have to perform one more step, and that is to define your parameters of beam and column. Okay, so why we need to do before performing that, we have to understand that why we need to uh, define the parameters of beam and column. Because as you know that that we are designing our beam and columns here, so to design that beam and columns, the parameters that we have to consider are like the size of the beam, okay, then like the number of size of the bars, number of bars, then the grade of bars, okay, then like your the material, that we have to consider it. Okay, so that's why it is very important before analysis to perform our this step, that is to define the parameters. Okay, so for that what you have to do, first of all you have to go to view and edit, and then here select. In select you have to click bar. Okay, so this is the slab, this one we don't want. So you can select one by one and then you can perform it. Okay, so first of all I'm selecting this. Let's do one thing, let's select all those, okay, together. Okay, so here all the beams and columns are selected together, because as you know that we have uh, given the size same size for the beam and columns. So you can perform it one by one also, or you can perform it together. Okay, so just now close it and then go to design, and here there is an option called required reinforcement of beam and column. Under that there is an option called calculation parameters. So you have to go to the calculation parameters, not code parameters. Okay, just click on that. Then you will get an option called standard. So I'll show you what is there inside this. Just double click. Though under parameter set you will get standard. Okay, then here are general. If you go to general, you can see here, if you untick as in a structural model, you will see the different materials options, name, characteristic, strength, unit weight. Okay, so it will take this options. Okay, otherwise if you click it here, then it will take the which is already in the model. Okay, the parameters. Then longitudinal reinforcement, you can see here all the different reinforcement here. Okay, and then clear cover, everything, characteristic strength. This is transversal reinforcement. Okay, the diameters of bar you can select from here. You can select the number of legs. Okay, whatever you want. But as of now I'm not going to do any kind of changes here, because we have already defined it, so we don't want to define from here. So just save it. Okay, close it and just click on here on the standard and apply. Okay, so it is applied. Now next we have to do the analysis part. Okay, so for analysis what we have to do, it's very easy to perform the analysis here in robot. So you have to just go to analysis and you can click here calculations, okay, or you can directly click in the calculation part. So just click here. So the analysis perform here. So we are getting here number of errors 0, okay, and number of warnings 2. So as you have seen, after analysis we got no errors in our model. So next we are going to calculate the required reinforcement of beam and columns, okay, both for beam and columns. So for that, what we have to do, we have to go to design, and here there's an option called required reinforcement of RCC beam and columns. Not this one, because we have use this command to set the standards, but this is not this option. You have to click on the above one, that is the required reinforcement of RC beams and columns. So as soon as you click on that, you will see a box over here, dialog box. So here we have to keep the calculation type design, calculation for members all, it will be all, okay, because we are going to design, we are going to calculate the reinforcement for both beams and columns. Now code combination list of cases, so we are going to select the limit state, okay. So just select this, all these loads, okay, just close it, okay. Now we have selected the load here. Now you can see all the members are shown here in the list below. All the sections or the different sections we have used in our models, the materials we have used here, then the type of columns, then the reinforcement parameters, written standard, we have already selected that. So you can see all the members are selected here. These are the beams, okay. So these are all the selected sections. All the sections are mentioned with the type here, okay. So now just we need to calculate it, okay. Just click on here calculate. Now the robot structure analysis will start calculating, okay. So we are getting an error contain warnings here, okay. We got a warnings and errors, okay. For detailed reinforcement errors, one is display the remarks column in the bar reinforcement table, okay. Just close it, okay. We are going to see what type of errors we have got, okay. Just close it, close it. So this is the table where we can see the errors, okay. So these are the general here design slab. So here you can see for all the members of column, okay, the required reinforcement along B direction, requirement along H direction, all everything is provided here. The transversal reinforcement type distribution, okay. Now beam info, so this is the beam info. So this is a complete detail of your beam, okay. Distribution reinforcement, top distribution reinforcement, bottom required reinforcement, bottom reinforcement distribution, transversal reinforcement, everything is provided here. So here this is the error, so just click here. So as soon as you click here, you can see we have found these are the errors, okay, from 24 to 20. 8. Okay, the bar positions. So if you click here in this arrow, then you can see in the model. Okay, so this is the arrow here. Okay, then this is another arrow here. This is another arrow here. This is the arrow, another arrow, and then this is another arrow. So this is another error. So error means maybe we have to change the section of this beams. Okay, so we don't have any kind of errors in the column, but we are getting some kind of errors in beams. Okay, so we have to change these sections. Okay, so as of now I'm not going to show you in this video how can we do that. Okay, right now I'm going to move forward. Okay, but later maybe I will show you how to do that, how to rectify all this error, how to change the sections. Okay, so how to minimize the errors. Okay, but as of now I'm going to move forward with my result diagram. So I'm going to show you the result diagram. Okay, so now next we are going to analyze, now we are going to see the diagram of our result. Okay, now what are the resultant diagram of this model? So it is very easy to observe the resulting diagrams. Okay, in robot structure analysis, so we can see the stress diagram, then we can observe the bending movements, then stress diagram, reactions, we can also observe the reactions. Okay, then your deformations. So there are different options. Okay, so we can select one by one and we can observe all the result. Okay, so now to check out the result, here is an option called layout. Just click on that and go to the option called result. So you will find different options of result, like result diagrams, result maps, detail analysis. So you have to go with the result diagram. Then here you will see a dialog box over here. Okay, so you can see there are different options like NTM, deformation, stresses, reactions. Okay, so you can select all those and check out one by one all the results. This is a reinforcement, but before doing that, first of all you have to go to the parameters and make sure that you change the diagram descriptions. Okay, the positive and negative values means how you want to represent the parameter means here you can select. Okay, the options, there are different options how you want to represent your diagrams. Okay, the your positive and negative values. Okay, how you want to do the feelings. Okay, like in the diagram, do you want to keep it like fence or you want to fill it with colors? So I found as per as me, I find this more better options like text. Okay, then positive and negative values like differentiated. Okay, and your filling, I always go with this filled. Okay, I think these three is the best options. Okay, then you have to just apply it. Okay, then just let us check one by one. Okay, so first of all let's go to NTM, and here there is a moment, forces, different forces, moments, and your reactions over here. So let us check one by one. Let me go to MZ movement. This is the bending moment. Okay, and just apply it. So you can check it here, the moments. Okay, here the maximum is 40.55 and the minimum is 40.26. Okay, then the MY. Okay, just go with MY, apply it. You just have to click here and just you have to hit the apply button, then you can see all the results here. Okay, next see the forces. Okay, let's untick this and let's see the FZ forces and apply it. See, you can see the forces. Reaction, let's go with KZ reaction apply. Okay, but one thing, let me show you here. If you want to observe in a better view, okay, then you just select here the just of these section shapes. Okay, and now let me show you fy apply. See, now the results are visible here. You can see the behavior of your moments very easily here. See, this is the bending moment diagram, okay, in the my direction. This is, let me show you, let me click all this, then you can see here. Let me only click the MZ and apply. Okay, so this is how you can see. Let's now see the deformation. Just unclick this first, then go to deformation, click here deformation and just apply. You can see here how the deformation is taking place. Okay, stresses, you want to see the stresses, you want to see the reactions, fy reactions, hit apply, you can see the reactions over here. Fz apply, see, you can see the reactions here. So it is very easy to here you can see the reinforcement, the required reinforcement and the provided reinforcement. Okay, so this is how you can check it. Let's go to this NTM reaction, just off it. NTM my apply, set apply. I want to show you here. So this is how you can check all your results, all the diagrams. Okay, so next what we are going to do, next we are going to check the provided reinforcement, okay, for both beams and column. So first of all, let us do for columns. Okay, so for that let me show you for a single column, and you can follow the same step for all the columns. Okay, so let me select any of this column. So let me select this, and then what you have to do is that go to here in the design. In the design there is an option called provided reinforcement of RC elements. Just click on that. We have to do a run analysis for this. Okay, so you can see here the RC regulations is given, the grouping type and all the informations. Okay, just click on OK. So here is a column. Okay, so all the descriptions, all the length, width are given here. Okay, so next what you have to do is that in the right hand corner you can see there is a calculation option. So just click on that. So these are some kind of parameters. Okay, these are some of kind of parameters which you can change in your calculations. Okay, so these are all the options for general category. Then here the concrete, here you can change the material name. Let me change it to C30. Then you can change the characteristics, strength, unit weight, aggregate size, whatever you want. Then longitudinal reinforcement grade is given here still. Okay, then transversal reinforcement is also given here. Okay, so just like if you untick this, okay, then the robot structure analysis won't take it, it won't consider it. If you stick it, then it will consider it. So just click on OK after that. Okay, then there is an option called reinforcement pattern. Just after the calculation option there is an option called reinforcement pattern. Just click on that. So you will get a dialog box here of reinforcement pattern IS 456-2000. So all the bars, that is the longitudinal bars, transversal bars, dual bars, okay, all the shapes are given here. You can change as per as your need. Okay, so these are the longitudinal bars, these are the different sections of transversal bars, okay, double bars, shapes. So whatever you want you can do that, but as of now I'm not going to change anything from here. Okay, so I have just shown you the procedure you can do. So just click on OK. Then one more thing you have to do before that is to check the code. Okay, we have to verify the code for that. So go to tools, and in tools there is job preference. So we'll consider two options from here. One is the unit and formats and another is the database. So from unit and formats you will be checking the materials. So the British materials here, it is British. You can take any of the options here, choose any of the options. So concrete, so we are concentrating in the concrete part. Okay, so in the database choose the option of reinforcing bars. So from here add new database, you can add a new database from here, whatever you want. Just you have to click here and just you have to add it. Okay, so just I'm keeping it same and just click on OK. Okay, so now next what you have to do is you have to start your calculation from here. So you can click from here as well, or from there is an options here under analysis, or here directly from the start calculation. So just click on that, click on calculate. So here in the upright top you can see this is the structure. So this is the column view which we have already seen. This is the column result here. All the descriptions are provided here. All the load types you can select here. Okay, this is the safety factors given here. Okay, now the column reinforcement, you can see the reinforcement is shown here. Just click on shift and the right button of your mouse, you can see the shape. Okay, now this is the column note. This is the, so we have selected the column 9. Okay, so this is the material properties, geometry, calculation options. So everything is provided here. Okay, the material survey, reinforcement bars, transversal bars, everything is written here. All the calculation are done over here. So next thing what you can do is you can check from column drawing. It is given in the right corner. Just click on that. So this is the column drawing. So I have saved this project as YouTube project, so it is given as here. So here all the column 9, it is written here. Cover, it's written here. Formwork, exposure class, mild. Okay, then maximum aggregate diameter, everything is written here. Size, it is written here. Okay, everything is written here. Reinforcement, shape, steel, number. Okay, so let me go to the geometry. So in the similar way you can do this, you can follow the same step for all the columns. For that you have to do just you have to select one of the column, then right click. Okay, no, not like that, just select any of the column here. Okay, then right click. Here is an option you will find select similar. Okay, then from here you can choose any of the option. Okay, but I think this is the most this select by bar type, then it will select all the bar types, similar bar types. Okay, so if you want to choose the beams, then it will choose only the beam part. If you want to choose the column, so it will choose. So select by material, it can take all the options of similar material. So I think it is the best option, that select by bar type. Okay, so see all the bars are selected here. Then you can follow the same procedure what we have followed for single column. Okay, so next we are going to see how we can do the same thing, how to do the provided reinforcement check for the beam. Okay, now we are going to do the same thing for the beam. We are going to check the provided reinforcement in beam as well. So for that, what you have to do, just select any of the beam here. So I'm selecting this beam. After selecting it, you have to go to design, and from here select provided reinforcement of RC elements. From here you can see all the loads are provided here, whatever we have defined already, dead load, slab load, okay, superimposed load, all are defined here. So just click on OK. It will do the analysis. Okay, so this is the beam. Now next what we have to do, just we need to do the calculation. We have to check the calculation parameters. So you can see here in general everything is provided here. Let's go to concrete and let me select here C30. The characteristics tag, unit weight, aggregate size, longitude reinforcement. So we don't need to uncheck here anything, the robot will take care of it. Okay, so we don't need to do any additional reinforcement. This was not there before in the column, so it is here provided, the additional reinforcement. So just click on OK. Now story parameters you can see here. So you can change the environment class, like mild, severe, whatever, very severe, most severe. Okay, you can change here. So let us see the reinforcement pattern from here. In the reinforcement pattern, all the reinforcement are shown here, like bottom reinforcement. Okay, so number of layers, so I'm going to keep it as auto because robot will take care of it automatically. Okay, so the top reinforcement, so I'm also going to make this auto. A transversal reinforcement, it's already in auto. This is construction reinforcement. These are the shapes. Okay, so here are the different sections. Click on OK. Now let us do the calculation. Okay, just start calculation. Calculate. So let's see, this is the structure. Okay, so this is the beam which we have considered. This is the beam view. This is a beam diagram. Okay, so you can see this is the bending moment diagram. Okay, this is the shear force diagram. This is the bending moment diagram. You can see the behavior here. Then this down one is your shear force. From here you can select, this is the reinforcement, this is the simple deflection. So if you check here, just apply it, you can see the deflection here. So this is the deflection pattern over here. Okay, so it is very easy to see all those things in robot. Okay, reinforcement, required reinforcement, apply. So this is the reinforcement area for bending, you can see. So you can check here one by one, and just you can see all the results over here in the graph. Okay, now let me see the beam reinforcement. So this is the beam reinforcement. Okay, now the beam note. So the calculations are given here. Similarly, we got in the column part, you can see these are the result. Now let us see the drawings. So this is the drawing of the beam. Okay, reinforcement, shape, steel, number, everything is given here. So we have considered the beam 41. So you can see the sections are provided here. The section, the stirrups, the diagram are provided here. So that was all about your beam part. Okay, the provided reinforcement of the beam. Now next what we are going to do is that we are going to see the required reinforcement of RC slab. Okay, so the next topic that we are going to start is the required reinforcement of RC slab. Okay, so for that what we have to do, that we have to go to design, or before going to design what we have to do, we have to select the slab. Okay, that we have to select the panels. And how to do that? So I have already shown there are two ways to do that. Okay, one is by just selecting the panels and just right clicking it, and you can let me show you. If you select the panels, and then you can select from here, select similar, then there's a different options you can select from here. Okay, or you can go to edit, and here you can just select that option called select. Okay, then from here just make it panel. Okay, because we are selecting our slab. Okay, so I'm choosing only this, I'm selecting only 150 mm slab. Okay, now close it. So our slab is selected. Make sure that only the slab are selected and not any other members like beam and column. Okay, so now it is okay. Then go to design, and here is an option called required reinforcement of slab wall option and required reinforcement of RCC slab wall. So if you go to the required reinforcement option, then there is a different options to check the parameters. Okay, so here this is the code parameters. You can see there is an RC shell here. Okay, or if you go to here and there is a code parameters, oh this is selected already, calculations. So you can see here a default calculation here you can do from here, but now we'll directly go to required reinforcement of RC slab wall. Okay, so it will start. Okay, now here there is different detail. Okay, so just click here area A required reinforcement and apply. Then you can see here the different details. Okay, like area, spacing, number of bars. This is the required reinforcement, this is the minimum reinforcement. Okay, now here is an option, there is a box here as plate and shell reinforcement, so we can calculate from here. So we are not going to do the verification. If you want to do the verification, then you can choose this option. Now we are going to calculate it, so just click on calculate. Okay, so it will start calculating. So it will take a little bit of time, but it will start calculating. Okay, so you can see here showing the required reinforcement area. So if you go with the number of bars and just apply it, so you can see here. So you can choose the options from here and you can see the result here. Okay, so this is how you can calculate the result. You can design the required reinforcement of RCC slab in robot structure analysis. Okay, so now let's come to the structure. Go to this dropbox menu and just select on structural model and geometry. So now we are in our model. Okay, so the next thing what we are going to do is that we are going to design our footing. Okay, footing for the building. So how can we do that? Okay, so we'll be considering two types of load in this footing design. One is SLS. Okay, and SLS is considered for the footing size, and the other one that we'll consider is ULS, and that will be considered for footing thickness and also for checking the punching shear. Okay, so now we are going to see that how can we first of all define the load combination. Okay, so for that what we have to do is come to the option called loads. Okay, then here there's an option called combination table. Just click on that. So under combination table, if you want to edit it, you just have to click here in the option called edit. Okay, so now we are ready to edit it. Okay, but before that let me right click it and just click on table columns. Okay, and I'm going to click on type of combination also. I'm going to add this also. Just click on OK. So here this column is added like combination type. Now we are going to enter the name here. Okay, so for that just click here. So we are going to enter here. Yes, so just click DL, then plus LL plus SIDL, and this will be your SLS. So combination type, here it will change to SLS. Case 1, coefficient 1, this is case 2. Okay, and this will be obviously case 3. Okay, so similarly now we have to add here as well. So DL plus LL plus SIDL, and this is your ULS. Combination type will be ULS. Case will be 1. Case 2. Okay, now here case 3 obviously. Okay, so this is how you have to define the load combinations. Okay, so there is nothing more to do here. You just have to close it. Okay, so we have now defined the loads. Okay, so next we are going to see how we can design it. Okay, so now we are going to design our foundation. Okay, so you have to follow this step one by one to design the foundation in robot structural analysis. Okay, so first of all let's go to the object inspector. There is an option under object of a model, that is floors. Just right click on that. Okay, and click on select all. Okay, so here the under groups and geometry, there is an option called general model geometry properties. Okay, so under general there is a name, different values, it's written here, and under properties you have to go to the thickness and just click on the different values. Okay, and I'm going to select 200 mm slab. I'm going to keep it constant. Okay, so just click yes, again yes, so it will take a bit time, just wait for some time. Yeah, it's okay. Now we have to select this, okay, to design the foundation. So go to plan, either you can go, there's two way actually, either you can go to plan, you can select, or from the 3D view also you can select. So from plan, how you can select, just click on plan, and from here this is the top of the stairs. Okay, so we are going to the base. Now just click here and select all this. Okay, and here you will get, here it is written, you can confirm from here, see it's written from 1 to 12. Okay, that means all the here it is selected. Okay, or you can go, let me show you the other way also. Now first click escape. Okay, then go to view. Then from here what you can do is that just click on shift and the right button of your mouse, and now just select it. So you can see it has selected all the 1 to 12. Okay, all the members here. So now it's done. So next you have to just click here, that is the provided reinforcement of RC element. Okay, so we are going to select it as manual combination because we have already defined the loads here. So just click on manual combination and just make sure that this is clicked here. Okay, this always display the dialog box and automatically run calculation, and these are all the loads which we have defined there, mentioned there, SLS and ULS. Okay, so make sure these are ticked here and just click on OK. Now you can see here, this is our footing. All the measurements are given here, all the details are given here. So now here you can see it's written foundation type and the geometry type. Okay, so this is an isolated foundation, this is the geometry type, it's rectangular. Okay, so the next option is spire, so it is doubled. Okay, so let's see the optimization. Let's set it as equal offsets. Okay, now just apply it. Okay, now let's see the foundation result. This is not foundation reinforcement, it's a foundation note. Okay, so we have to change the parameters also to get the result. Okay, so just go to this parameters. From here this is the calculation option. Okay, so here you will get different options like general, concrete, longitudinal reinforcement, transversal reinforcement, additional reinforcement. Okay, so this is the cover, this is C1, this is C2. Okay, so concrete, here the name, let's change it to 630, let's increase it. Characteristics, tank, everything is written here. Longitudinal reinforcement. Okay, then transversal reinforcement, additional reinforcement. Then here this is the reinforcement patterns. Okay, this is the footings, pier. So this is a different options of reinforcement type. double bars, shapes. Then this is the load definition. Don't need this right now. This is the soil definition. Okay, this is a soil definition. So all the parameters of soil definitions are given here. ठीक है, अभी यहाँ पर है soil. This is a geotechnical option, so this is very important to set the stress. Okay, so here it's, I have changed this to allowable. Okay, and I have changed this to 1.5 and just click on OK. Or you can just save this as user defined. Okay, just user defined and click on OK. Just click on OK. Now we have to go to this option start calculation and we'll start calculating it. So you can see now here the design combinations is here. Okay, this is the foundation view, this is the foundation result, this is the foundation reinforcement. Okay, so this is the foundation reinforcement, you can see from here. So it's very easy, isn't it, working in robot structure analysis. So this is the foundation note here, and now we can see the drawings as well. So see, this is the drawings. So it is very easy in robot structure analysis. So it just came in the form of sheet. Okay, this is a plotting drawing. You can see all the informations are given here, all the drawings are provided here. Okay, so let's go back to the geometry. Okay, so guys, you can see the foundation is drawn here. Okay, this is the plain view of our foundation. So this is how you can design your foundation. So just go through the video and practice it thoroughly. You will definitely find it easy as compared to other software. Okay, so this is the end of our tutorial series. So if you like the video and want to learn more about this software in complete detail for more complex structure, then please comment down below. I will definitely make video on this software. So myself, Anupama Roy, signing out of this video. Thank you.